This prototype shows the angle of arrival-based authentication, jamming detection, and secret key generation. Here are the key components of this prototype. It's a fully GUI-based prototype, which allows the user the flexibility to control what they would want to demonstrate. So to our left here is the control panel, which allows the user to select the attack scenarios, meaning a user is able to select either a jamming attack, whether they want to demonstrate a jamming attack, a spoofing attack, an eavesdropping attack, or all three attacks. Note that once a user selects the jamming attack scenario, the user is able to select the jamming intensity that we want to demonstrate, maybe a high jamming intensity, for instance, and also select the SNR levels, which can be low, medium, or high. Next, we also have on the control panel the node management component, which allows the user to select a node. The user node, which is the legitimate user on the network, the jammer node, the spoofer node, the eavesdropping node, and then also allows the user to start the demonstration and then to reset or clear. On the right, we have the node placement segment, which allows the user to place the selected node on the grid. We're using a Massive MIMO indoor data set. So once a user selects the node, the user is able to place on any position on the grid here, and then start the simulation. Once all the selected nodes are placed on the grid, the user can start the simulation, which calls the jamming detection, our jamming detection mechanism, the spoof detection mechanism, the security generation mechanisms in the background. They work in the background, and then the various outputs are shown on the different segments here. For the jamming detection, the output is here, showing the true jammer position, the estimated jammer position, the selected SNR levels, and then the SNR at the jammer cell and the SINR at the user cell. So next, let's start with this. We select the user node, the legitimate user node, and place on the grid. We select the jammer node, place on the grid. We select the spoofer node, place on the grid. We select the eavesdropper node and also place on the grid. After placing them, user can go ahead to start the demonstration. Here we can see the estimated position of the jammer and the true position of the jammer are the same. So our system is able to perfectly estimate the position of the jammer and also detect. So it's a twofold process. We first determine the position that we detect that the presence of a jammer in the network, and also estimate the position in the network or on the grid where the jammer is. And we have a perfect match here between the estimated position and then the true position of the jammer in the network. And here we can also see that the SINR at the jammer cell is about 9.53 dB, while the SINR at the legitimate user, it's about 27.77 dB. For the spoof detection, the spoof failed. We're able to detect the spoofer with a 99.8% accuracy. So we are able to perfectly estimate the presence and the position of the spoofer in the network, and the difference in the arrival in the angle of arrival between the legitimate user and the spoofer is about 5.54 degrees. They are very close, but we were able to detect the presence of the spoofer. Note that we have this yellow colored zone here, which we label the ambiguous zone. It is a zone within which, if the spoofer falls within this zone, it becomes increasingly more difficult to detect the presence of the spoofer. This is because the angle of arrival uh, of the spoofer will almost be identical, the same as that of the legitimate user, which makes the detection more difficult, not impossible, but makes the detection more difficult and with less accuracy. Next, we see the secret keys of Alice, which is the legitimate user in our case, and then Bob, which is the 64 element ULA. We see a perfect match in the keys, and the reconciliation rate is 100%, meaning we are able to accurately reconcile the Alice's and Bob's bits. So we have been able to demonstrate that our system successfully detect the jamming attack and then estimate the jammer position. We've also been able to, based on the angle of arrival, detect the spoofing the spoofer attack in our network, and also perfectly achieve a 100% reconciliation key reconciliation rate. So for this same position, we can choose to change the SNR levels to maybe low, for instance, and maybe the jamming intensity to low, just to show how our system will perform for the same position under different SNR and jamming intensities. So here we can see that jamming is still detected, and the estimated positions are still perfectly estimated, as is the same as the true jammer position. And interestingly, here we can see that the SINR at the jammer cell is 19.14 dB, while the SINR at the user cell is plus 19.99 dB. Very close. The SNR at both cells are very close, yet our system is able to detect the presence of a jammer in the network. We can see also here the spoof also still failed with the 99.8% and the angle of arrival. The difference in the angle of arrival between the legitimate user and the spoofer is still about 5.54 degrees, and the reconciliation rate we still achieve a 100% reconciliation rate. Next, I will try to show how our demonstrator performs when all the nodes are in close proximity. So we clear this up, and then we select the jamming, spoofing, and eavesdropping attack scenarios. We place the user on the grid, the legitimate user. We place the jammer very next to it, the spoofer also close to it, and then the eavesdropper as well, very close to it. So we want to see how our system will perform when we have these positions very, very close to the legitimate user. Here we can also see jamming detected perfectly. The estimated position perfectly aligns with the true jammer position. And then, even though the SINR at the jammer cell is very close to the SNR at the user cell, just 19.2 plus 19.29 dB and then plus 19.89 dB, we detect the presence of a jammer. So here it falls on the undefined zone because both of them are in the ambiguous zone, but we can see that the spoof rate is about 99.6%. So this is what happens when the the legitimate user and the spoofer, you can see the angle of arrival are almost identical. That is why the difference in the angles of arrival here is just 2.15 degrees. For the secret key generation, we can also see that the reconciliation rate is 100%, meaning there is a perfect match between both the legitimate user's key and then hashed key, as well as the 64 element ULA key. Next, we will try to see if when the nodes are far apart, what happens when the nodes are far apart. So we place the legitimate user very far from, reasonably far from all the points, and then we try to estimate the performance of our solution once again. So for the jamming detection, we can see that the estimated jammer position still perfectly aligns with the true jammer position. Also, even though the difference in the SINR at the jammer cell and the SNR at the user cell are still close, just 18 plus 18.46 dB and then plus 20 dB respectively. For the spoof detection, we have a spoof rate of 99.8%, and also the difference in the angle of arrival between the spoofer and the legitimate user is about 8.32 degrees. And for the secret key generation, there is a 100% reconciliation rate as well, showing a perfect match in the keys generated by Alice, the legitimate user, and Bob, the 64 element ULA in this case. So users should be able to play around with different scenarios, with different SNR levels. Here we can choose to change the SNR level to, let's say, medium, and then maybe the jamming intensity level to also maybe medium, to see how our system still performs. Here we can see the jamming detection, also and similar, the estimated position of the jammer. Jamming is detected, the estimated position of the jammer perfectly aligns with the true position of the jammer. So we are able to still, with medium SNR level and then medium jamming intensity, we are still able to perfectly not just detect jamming, but also estimate the position of the jammer in the network. The SINR at the jammer cell here is 15 plus 15.22 dB, and then for that at the user cell is plus 24.99 dB. So for the spoof detection, we still have a detection rate of 99.8%, while the angle of arrival is still 8.32%. So this will practically not change, because the spoofing detection mechanism uses basically the angle of arrival for this process. And the reconciliation rate is still 100%. So far, we've been able to show for different scenarios, close randomly placed nodes, nodes being close to the legitimate user, and nodes being far from the legitimate user. In all scenarios, we have been able to, and for different SNR levels and jamming intensity levels, we've been able to show that our system is able to not just detect jamming attack in the network, and also perfectly estimate the position of the jammer in the network. For spoofing, we've also been able to detect spoofing attacks with over 99% accuracy, almost 100% accuracy for all of the scenarios, and we've been able to achieve a key reconciliation rate of 100% for all scenarios. So you can play around with the prototype for different position, place at any position on the grid, and further see the performance of our solution. Thank you very much for taking your time to watch this video.